This section, we're going to call it simplifying square roots, part 1. The date is 1/14/14. First of all, we need to understand what square root of x is basically saying to us. You guys know how, multiplication is asking you to do something, right? It's an operation. When they say 3 times 4, they're basically saying you got 3 4s, how many do you have, right? This is the same thing as multiplication, division, addition. It's asking you to do something with this number. And what it's asking you is, what number could I multiply times itself, or square, and get x as the answer. As an example, square root of, well, if you think of the numbers between 1 and 16, we'll say. There's 16 whole numbers there, correct? How many of those do you think you can answer that question? There's a lot more numbers you can't answer the question than you can. In other words, square root of 1. What number could you square or multiply times itself and get 1 as an answer?
1.
Yeah, square root of 1. Don't write this down. It's 1, right? How about square root of 2? Could you answer that question?
Yeah.
What number? Tell me, what number could you square and get 2 as an answer? Tell me exactly.
4.
It's a decimal. And guess what? You can't write it exactly as a decimal because it's non-repeating, non-terminating. It goes on forever. So really, even if you use a calculator, you can't exactly answer that question. Okay? Square root of 3, can't answer that one. Square root of 4, 2. Okay, there's one I can answer. Square root of 5, can't answer that one. Square root of 6, you may think it's 3, but it's not. Because what's 3 times 3? That's not the answer to that question, is it? Square root of 7. And like I said, you don't have to write this down. Square root of 8, you can't answer that one. It has nothing to do with being even. I'm asking what number could I multiply times itself and get that as an answer? Square root of 9. There's 1. Square root of 10. Square root of 11. Square root of 12. Square root of 13. Square root of 14. Square root of 15. Square root of 16. 4. So there's 1, 2, 3. Only 4 out of 16 numbers could you answer that question. Okay? And like I said, writing as a decimal is an approximation. It's a good approximation if you take it to 10, 20 digits. But when it's all said and done, it's an approximation because it goes on forever. Let's put that stuff up, please. Now, so what we're going to learn is how to simplify some of these to make them get as much outside of that square root as we can. That is the concept of what we're going to do. Okay? And it all starts with these numbers right here. And these numbers are called perfect squares. Very, very important. We are going to write 20 of them out. There are an infinite number. The smallest perfect square. Actually, it's 0, but the smallest useful one is 1. Yes, it is. But it won't have any use for it. Does anybody know what the next perfect square is?
4.
You are right. You know what the next one is?
9.
How about the next one?
16.
How about the next one? How about the next one?
36.
Next one.
49.
Next one.
64.
Next one.
81.
Next one.
100.
So far, does anybody see a pattern here? Okay, we'll keep going. What's the next one? What's the next one? Next one. 169. Next one. Next one. Next one. Quit whining. I think the next one's 289. I think the next one's 324. Then I think the next one's 361, and then I think the next one is 400. How many do y'all have there? I think that's right. Does anybody know why these are perfect squares? Yeah, they're the numbers. The reason is because this is 1 squared. What is this one?
2 squared.
What's this one?
3 squared.
What's this one? This one? Just keep going, don't we? So you guys finish this, help me finish this out. Draw your little arrows.
Oh, I see the pattern now.
Yep.
Okay.
See the pattern? And basically, it's going to go on forever and ever. And each time, just whatever x squared is, that's what your perfect square is going to be, isn't it? Okay? Anytime you put a number in there and you square it, it's a perfect square, isn't it? So now you see why there's an infinite number of them. Because we could just keep going on and on forever and ever, couldn't we? These are significant because these are the numbers that we're going to use when we simplify square root. Because, does anybody else know why these may be important? Why do you think these numbers are important when it's dealing with square roots? Anybody have an idea? They come out even. Very good. The square root of 1 is equal to what? Square root of 4 is equal to what? See how I'm putting the perfect square under the square root? What do each one of these come out to be? They're the only ones that come out to be what? Even when you take the square root of them. So those are the ones, numbers that we can, these are the numbers we can get outside of the square root sign. We have to have these numbers underneath there in order to be able to find to get them out, things out from underneath the square root. So these are going to be useful when we're trying to simplify a square root. A lot to write down, isn't it? Okay? But the main thing to understand is when I'm talking about write your perfect squares down, which I'm going to have you do in your assignment, write them all to the side, which numbers here are the perfect squares? These are just reasons why, right? The actual perfect squares are what? 1, 4, 9, 16, 25, right? Those are the perfect squares because those numbers, when you take the square root of them, what do you get? They come out even, okay? As you would imagine, when you have like square root of 16, you can answer that question, right? The answer's 4. What we're going to do is I'm going to do one example before I write down some steps. And what we're going to do is we're going to simplify square root of 12. And the whole reason we can simplify things is for this property right here. The square root of a times b, all underneath the square root sign, okay? You can always write split up into two separate square roots as the square root of a times the square root of what? That's how we split it up and get perfect squares out of it. So basically, if there's a perfect square as a factor here, I can get it out. See, if you're looking at this over here, if you're not done with your perfect squares, look up here for a second. Look how I can split square root of a times b into square root of a times square root of b, right? How could I split this up to where one of them would be a perfect square and I could get some of it out? Think about the number 12. Make it into a multiplication problem where I have a perfect square in it. 3 times 4? Everybody agree? Why? Because 4 is a what? Is 4 on my list? So what I would do is I would tell you guys now, split this up into square root of 4 times square root of 3. Now they're two separate square roots, aren't they? So that I have two separate questions, don't I? So what is the square root of 4?
2.
See, that becomes 2. So I got that much out of it. But I still have what left underneath it? So that's how you simplify that and write your answer. That's how you simplify a square root. You basically find perfect squares that will factor into it. For square root of x, 1. Your first step is x a perfect square? If your answer is yes, evaluate it. If the answer is no, go to step 2. The reason I have that as a step is because you'd be amazed at how many people, I write square root of 100 and they break it up into square root of 4 times square root of 25. Then it's square root of 2, then it's 2 times 5, which is 10. They did more work than they had to, didn't they? Because the number underneath the square root, if it's a perfect square, I can answer the question, can't I? You know, that's an easy one. So make sure it's an easy one first. Agreed? You know, make sure you got, because some of these down here you probably don't know by heart, do you? If I put square root of 361, you think it's just going to pop in your head that that's a perfect square? Probably not. So look on your list. It is. Good. Answer is 19. But if no, go to step 2. Step 2. Find the largest number that is a perfect square and a factor of x. We're going to call this our perfect square factor. And of course, I'm going to call it your PSF, perfect square factor. Like, GCF, greatest common factor. This is our greatest perfect square factor. The reason you do this is so, 3, using the PSF you just found, split square root of x up using that PSF. So how am I going to split it up? By making it into a what? Multiplication problem, right? You see how I split this up? Would it have been, and everybody stop for a second, would it have been right to say 4 times square root of 5? Square root of 4 times square root of 5? No, because what's square root of 4 times square root of 5? Square root of 20. Well, what did I start with? Square root of what? So once you find your perfect square factor, you need to make sure multiply it times the correct number that gets you what you started with, right? So that's what I mean by splitting it up. Evaluate your perfect square factor radical. Radical is another name for square root sign. Then make sure what's left under the square root is simplified. And I'm going to give another kind of statement over here for how you know whether something is simplified. A radical is simplified if its largest perfect square factor is 1. Because if you split it up into square root of 1 times that, it's just going to get the same thing, because square root of 1 is 1. 1 times anything is the same thing, right? You'll get right back to where you started. And I don't expect these necessarily to just click right now until we kind of talk about them and do 3 or 4 problems with it. Okay? Terrence? Stop working on other assignments this instant, because I'm telling you, you won't be able to do this, and you'll be up at my desk asking me how to do it. And that's going to upset me, because I'm doing my best to try to explain it to you right now. I don't mind explaining it again if you listen the first time. But then again, you at night before you go to bed, you make sure and watch lectures from each day, don't you? All right. Once everybody's got this down, we'll do some examples. Kind of try to
What is that word that's after making on number 4? It says like swing.
make sure, sorry. There we go, that's a little better. And that's what's left under the square root is simplified. A radical is simplified if the largest perfect square factor is 1. Ethan? How you doing? What you doing? You got it all down?
Yeah.
Attaboy. All right, how we doing? We good? Hmm? Okay. Okay, our first example. Let's do square root of 100. If I go through my steps, what do my steps say? Is the number underneath the square root sign a perfect square? Is it? Is it on my list? Giddy up. That means it's easy. What number squared is 100? Don't make life hard on yourself by not doing one like that. 2. Let's try square root of 30. Please don't talk. Now, here's something I want you guys to think about. Think about dividing into numbers. Tiffany, tell me this. Answer this question for me. If you had any number in the world, what's the largest number that can divide into it? Of any number in the world, describe to me the largest number that can divide into it. Evenly. True. What is the largest number besides itself that can divide into it evenly?
15.
I'm not talking about this one. Any number. How did you get that answer? What'd you say?
Half.
Think about it. Isn't half of number besides itself the biggest number that can go into it? Besides itself? So like, what's the largest number that can go into 100? Besides 100? 50. Oh. Then it's, like 99. The largest number that can divide into it evenly is, if you do decimals, 0.5, right? In other words, half the number, 48.5, right? The reason I say that is because you can look at some of these numbers, and basically I'm looking for the perfect square that's a factor of 30, aren't I? What numbers can I knock off the list right now to not even have to try? And what I'm saying is you can, for people that aren't great at knowing your multiplication tables, you can use what? A calculator, right? And just put them in and start trying. For instance, where should I start with the number 30? What other numbers can I? 30 divided by what? There's no number bigger than 15 other than 30 that will divide into it evenly, is there? So when I come over here to my list, what numbers and up do I need to not even worry about? 16 and up. The only possibilities are what? 9, 4, and 1. Start at the biggest. Will 9 divide into 30 evenly? If you don't know, go 30 divided by 9. What do you get? Decimal. Doesn't go evenly, does it? Next one, so that one's gone. 30 divided by 4. That one's gone. So what's the only one left? What did I say? What does it mean if a radical is simplified, the largest perfect square factor is? So is this one already simplified? Yeah, there's nothing we can do about it. So guess what the answer is? Square root of 30. It's already simplified. So you see, there are some really easy ones. Now, those aren't necessarily easy because, on a big number, you may have a lot of different numbers to try, huh? But if you start just going down that list, you'll be okay. Let's start with another one. Square root of 32. Now, where should I start with my numbers? 32 divided by what? Start at half of it. Start with the number 16. Is 16 on our list?
Yes.
It is. So what's the largest perfect square factor? So 16 times something is 32. 16 times what? Well, look at your... But they both have to be under a what? Its own separate square root sign. Of course, I'm going to expect you to put this on your papers. So what is the square root of 16? Do you see how this comes out of the square root? You can't answer that question, can you? So it just comes down with it and it stays the same. What do you think about that? That's not that bad, is it? Do you understand, why we're wanting perfect squares? Because if we can pull that out of there, that perfect square out of there, if it's a factor of it, I can get the most outside of the square root sign as I can. That's the whole idea of simplifying it. Because this is an exact answer. Doing it as a decimal is not exact. Questions on that? We okay? Let's try one that's got a little more to it. Let's try square root of 150. Now, even if you see this right off, give us some time here. Okay? What number do I need to start at? Well, what's 150 divided by 2? Okay. So I go over here to my list, and basically 75 is right here, right? So I need to start at what? 64 and up. Some of you may be able to see this. 150 divided by 64. Okay, it's not going to come out even, is it? What's the next one? 150 divided by 49. And I'm doing this the long way. Some of you can see in your head that that doesn't work. But let's be honest, this isn't taking that long, is it? So I can knock that off the list. 150 divided by 36. That one doesn't work. 150 divided by 25. Does that one work?
Yeah.
So I split this up. Put your perfect square factor first. So it's square root of 25 times square root of what? 6. Agreed? Do you see how this and this, when multiplied together, you're getting the same thing?
Yeah.
So what is the square root of 25? So 5 square root of what? Do you see how that's what can come out of the square root? Now, when I was talking about is it simplified, well, what's the largest perfect square factor of 6? That's why that one's simplified. Are there other ways to do this? Yes. Some of you may have been taught, like for 96, okay, square root of 4 times 4 will probably go into 96. Some people have been taught like this, so if you haven't been or you don't care to know, don't listen. Okay, square root of 24. That becomes 2. Can that split up anymore? All right, that'd be square root of 4 times square root of what? 6? Agreed? So it's 2 times what? 2 times square root of 6. Can square root of 6 split up anymore? There any perfect squares besides 1's factor of it? So what's your answer? 4 square roots of 6. You can do it that way too if you want to. You know, on some of those really big numbers, I almost suggest it. See if the 4 go into it just to get yourself a smaller number to deal with. As long as you realize, you know, and write this as number 5. But on a number like 96, you could also just do some division and figure out that it's 16 times what? 6. Which is why you got 4 square roots of 6. And something like that, either way could be as fast. My deal, actually the calculator I think I advised you guys to get actually simplifies square roots for you. So you can use that to check, or work backwards. But, what do I want you to do? Yeah, because things you're going to have on an EOI test for Algebra 2 and things like that aren't going to do these for you. Okay? Right? Okay? So I want to see your perfect square. I want it to look exactly like I did. Nice and neat. Okay? Working down, splitting them up. All right.